Morning, I'm Ian McNicoll. As Francesca said, I'm co-chair of the openEHR Foundation, which is a not-for-profit, as you'll discover in a moment. Thank you so much for the invitation to come back to Puella to Sardinia. As Francesca said, I was actually here at that meeting 11 years ago. I was sitting in this room. Last time I had two very glamorous Italian ladies translating me into Italian. I'm very sad I didn't get to hear the transcripts in Italian, because I'm sure I sound much better in Italian than in Scottish. Certainly sexier. So it's a great pleasure to be back. It's a beautiful part of the world, and thank you very much for the invitation for all of us to be here. I'm going to give you a quick, gentle introduction to openEHR. It is a different and somewhat difficult paradigm sometimes for people, because it is quite revolutionary in its thinking. It doesn't have to be revolutionary in its deployment. It's something, and Tamaj will talk more about this, that can be introduced to an e-health system without suddenly breaking what's there already. So I think of it as a gentle revolution, but definitely allowing your health IT systems to evolve. So, what is openEHR? And I should say, sometimes we say openEHR, sometimes we say openEHR. It's just easier to say openEHR, and it allows us to market things better. So if you hear openEHR, openEHR, exactly the same thing. It is an open specification, right? So this is important. It's not open source software as such. There isn't an openEHR app that you can go and download, or an openEHR library that you go download running your system. It's actually a specification for a health information model, and that is capable of supporting what we're calling an open platform ecosystem. We'll explain what that means in a little while. But the idea is to make the health record, and the record itself, not the applications that sit on top of the health record, but to make the patient's health record, or indeed citizens' health record, vendor neutral and technology neutral. In other words, stripping some of the things that traditionally are inside, if you like, legacy vendor systems with all the usual problems of vendor lock-in and siloing of data. We're trying to solve that problem, but we're not trying to build an open source application as such. It's just about the data. It's licensed. openEHR, the specifications are completely open themselves, Apache type licensing, but they're licensed to allow both open and closed source deployments and developments around that, as long as people accord to the standards, the open standards. openEHR itself is a small not-for-profit. We think we punch well above our weight in terms of the size of the organisation and the resource we have. But it is now very genuinely an industry, clinical and health organisation collaborative of people around the world who believe that this is a much better way, in fact possibly for the future, the only really sensible way to be building health systems and solve some of the very fundamental problems we have in trying to digitise healthcare. So one of the phrases I've used in here is an information model, and in my experience it's one of the things that people are often not so clear about. Certainly people who are policymakers or strategists, who are clinicians, who are not technical, will sort of struggle to understand what an information model is, and the information model is at the key of what openEHR is about. So I've said this is any definition of the structure and content of information that we want to collect or share. And on that screen, you can see there's a form, effectively, a paper form. So this is a form we use in the UK that allows clinicians to explain what a patient's end-of-life wishes are. Specifically, does the patient wish to be resuscitated or not? Now that's on paper, but in a sense that is an information model, because it's not a blank sheet of paper. It tells the person who's entering the data how it should be entered and what questions should be asked. So it's constraining the user of that form to answer the questions in a specific way. Of course, that's paper. What we're trying to do is to digitize this world, but essentially to guide, to help people collect data in a consistent way so it can be moved on to someone else. Sometimes people call an information model a minimal data set. It could be part of a message or interface definition, but fundamentally every single application almost certainly has some kind of information model inside it, usually expressed in a programming language or some other technical format. And it should be clear that sharing information needs us in some way to share those information models. And the big problem we have in healthcare, actually in any industry, the big problem of interoperability, of moving data between different systems, is fundamentally that of mismatched information models. This is an example from the UK. This is a real example, sort of dumbed down a little bit, of the difference between the way that a hospital system thinks about medication data from the way that a GP or community system thinks about healthcare data. Or maybe there's another app for patient-facing apps. It has its own information model. It has its own way of thinking and representing this information. And they don't line up. And they don't line up for two reasons. One, those information models come out of the heads of people like myself. So I was originally a GP, a clinician, got interested in health IT. And I would be the one that a developer would come to me and say, Ian, you want us to build an application to help with medication, GP medication. What do we need to do? So the business of building information models is largely about developers talking to domain experts like myself and Heather and Celia, and finding out what it is they mean by a medication. How do we do a prescription? What's required in that? And of course, we give our honest and best view of what that should be. But if you were to ask me, and then to ask Celia and to ask Heather, you would almost certainly get different answers, because we're human beings. We don't know everything. We may not be real experts on medication. We may be working in different sectors. So there is a reason, actually. It's not arbitrary, it's not accidental that in the UK, the GP medication model is different from the one in a hospital. There is actually a structural reason behind that. There's a valid reason behind that. But very often the differences in clinical information models are somewhat arbitrary. It depends who was asked at the time. And we often, as individual clinicians, do not have a terribly good wide view of what our other colleagues might need. What do nurses need rather than doctors? What do physios need? What do patients need? So we are very siloed in our thinking because we tend to work in a siloed way. But there's a deeper problem. So this isn't just, in my view, just about interoperability. It's about the way that we build systems and the cost that we impose in the way that we build systems. So what would typically happen right now is that a clinician and an engineer would get together and decide they're going to build an app. In this case, it's based around some mental health applications in the UK. I need to build a mental health app. So a clinician goes to the developer and says, this is what I need. They have a conversation and they come up with a model about, okay, this application has something to do with beds and mental health. Well, how do we model a bed? So we get all sorts of ideas from the clinicians and other people within that hospital, and they come up with a model of a bed that they're going to use inside this application. But somewhere else in the UK, there's another vendor and another clinician working in the same space, working in the mental health field, having the same sort of conversation. And these are long, difficult conversations. Health data is complex, and it's hard to have those conversations. And they come up with a different idea, and they build that into their application. So both are talking about bed, but they've both got different models now. And then you've got a third, a new dynamic application. Much nicer idea of a bed, but again, it's different. These things are all different. So when they try to talk to each other, we have a problem. So how do we currently solve that problem? Well, currently, what generally speaking we do is we build yet another model, right? So we get another bunch of clinicians, another bunch of technical people, and we build, if you like, external information models, something that joins these all together, and everybody can sort of agree. The problem is they tend to get a bit dumbed down because doing that further bit of analysis takes time, it's difficult, there's politics, there's culture. So now we've got effectively 4 information models, one in each of these applications, and another of them one that we've designed as our kind of agnostic one that everybody can talk to. But the business and the work doesn't stop there. What we now have to do is to write the software to transform the data between all these different formats. So yet another group of expensive people, and I'm one of those expensive people, so I quite like this system. This isn't a bad system from my pocket point of view. Another bunch of clever people, engineers and clinicians, because this is clinical safety stuff, it's hard to do, write some software to map from this Rio application to something like HL7 Fire. And another bunch of people do the same thing there, and another bunch of people do the same thing there. And it's not really money laundering, but it sort of feels a bit like this at this point. The point is there's a lot of cost that we're putting into building health IT systems because we're creating knowledge in a disconnected way, then trying to join it all up together in an agnostic way, and then having to build the software to make that run. What we're trying to sell the idea in openEHR is that you do not have to work that way. And this idea is the open platform. Let's separate the data from the apps, and let's separate the data definitions from the technology that stores and queries that app. And this is the fundamental architecture. Yes, let's have as many apps as we can. This is not about having one big application that everyone uses. We need that variety. Down the bottom, we have technology-neutral data stores, specialized data stores called CDRs. They will have some kind of physical database inside them, but we want to abstract that away. And we want those data stores to talk to the apps, and the apps to talk to data stores through this vendor-neutral information model via standard API with a standard query language, we'll talk about that in a second, called AQL, and in a no-engineering way, so that those information models can be immediately deployed by that technical layer. But that technical layer has to be provided by multiple vendors, and it has to be provided using any variety of technologies. We're not locked into one database product or even one style of database. It could be SQL, it could be NoSQL. So that's the vision. And that fundamentally is what openEHR is trying to deliver. And the slides are going on and on. So in a sense, this is what we think should work. This is the way we think things should work in the future. We start with the models. We start by thinking about the models. We start to build the models. We get as many people involved in the discussion of the models as we can. We want as many perspectives on what a bed might be. Or it could be an allergy or a blood pressure. It doesn't matter. I'm just using bed as an example. And we get patients and clinicians involved, patients and carers involved. This isn't just about the professionals. And we build the best models we can. And then having done that, we hand these off to these back-end service providers, the CDRs. And then they actually work directly with the apps developers. So the apps are working through these CDRs and using these, as far as possible, those shared models. And Heather and Celia will talk about the modeling process in more detail, about how we actually govern that. So we've got this separation between apps and the data. The data lives in a vendor-neutral, technology-neutral format, which all of these apps can talk to. And of course, the idea is that the apps can work with different data stores and can swap between them. So we're building a new kind of market. You know, it's just kind of, it's almost Amazon Web Services territory, cloud-based hosting, that kind of idea. And this is what openEHR is about. Will we still need things like HL7 Fire to hook up and integrate? Yes, of course we will, because there are always going to be systems that are not built this way. So we absolutely will need those integration technologies, and you were going to have this session later on where hopefully we're joined by Graham Grieve from Fire to discuss how openEHR and Fire are similar, but in many ways why they're different, because they're trying to do different things. And they will need to live together, and actually can live together quite nicely during this phase. But the idea is that gradually, if we get this right, we will reduce the requirement for everybody to keep building their own information models, because we can share these things in an open way, and reduce the requirement for more expensive technologists and clinical informaticians like myself to build the mappings between these different siloed bits of data. At the core of openEHR, there are essentially two sets of technology. One is the clinical modeling, and Celia and Heather are going to talk a lot more about that and the process of how we develop these things. Fundamentally, there are two things. There's openEHR archetypes, which are components, things like what's an allergy, what's a problem, what's a blood pressure, what's a genomic variant. And these are the core of what we build. But they're designed to be not specific for any use case. We talk about a maximal data set where we try to get as many perspectives as we can, build them into those components. And then those components are used in a variety of different contexts, in a variety of different applications. How do we do that? We use another layer called templates that brings the archetypes together, constrains them to fit a particular use case, accepts that some of the data points in this maximal data set archetype are never going to be used. So for instance, the blood pressure archetype we have has something like 20 or 30 data points. As a GP, I only ever use maybe 2 or 3 of those. And the template, I would have a template local to my system or my application that would constrain that right down and say, look, we only need these 3 things in my particular setting. The templates are also the technical layer, or at least the handoff layer, that having delivered the template as a clinician or clinical informatician, That's what I hand off to these technical CDR systems. So having built the templates, effectively the modeling work is done, and then the whole point of the CDRs is that they understand how to deploy templates directly without any further engineering. So it doesn't go to some database engineer who works out what the table structures should be or how they might change. It just works out of the box once the modeling is done. Here's some examples. One example, the CSR4 group and HiMed colleagues from Germany who are here have been collaborating on a set of genomics archetypes. It's what we were talking about yesterday. What we do is we share them in open source. Anybody can use them free of charge. And we use a tool to do the clinical engagement and to help us review these archetypes and make sure they're good quality. That's something that Celia and Heather will talk about much more later. We use a set of custom tools to develop these things so people are not dealing in any specific programming language. And this is very much my sort of domain. As a clinician or clinical informatician, Heather and Celia use these tools to develop the models. We're not engineers, we're not programmers. We use the tooling to develop the models, then they get deployed very quickly. So it's a very different kind of world. And the whole point about this is to try to get a good set of good quality archetypes that we can reuse in quite different settings. Different templates which will generally underpin some kind of application or possibly a message. There's a set of archetypes that are used in 2 different applications, but we're sharing as many of those components as we are. So this is about building widgets. It's about building data information widgets that can be reused within applications. And the point is that, of course, it's not just in a single application. We can have multiple applications talking to the same data store, possibly for variations in the community of use. So what we're aiming at is this kind of open source collaborative clinical content factory where we as clinical informaticians build the models, then we hand them over to the technical guys and they can do all sorts of clever stuff with it after. And Tomasz will show you some of that as well. Let me just come back to this idea of the CDR, the bit at the bottom. And I meant to take all those builds out, I'll skip them back. So the CDR is a smart data store. It has a logical standard layer around that, and that is what openEHR defines. It defines the standards that sit around the data store. So much of the work that's done in deploying openEHR is actually about how do you build a CDR. That's one of the critical bits. How do you build a clinical data repository? And one of the key things that it has to do is have this idea of AQL, Archetype Query Language, information model querying. The querying is independent of the actual database. Right? As a clinical modeler, and I do some of this, if I'm writing the queries to get data out for an application, I don't have to know, in fact I shouldn't know, what is actually sitting under the hood. There could be a SQL data store, it could be a NoSQL data store. In the openEHR world, you don't care. In fact, you should be able to swap between different back-end CDRs and keep running the same AQL and they'll keep working, even though they're based on quite different technology inside. So to query an openEHR system is also, that's all you have to know is what archetypes and templates are inside that system, and that is all open to you. So the data formats and the data structures that are inside the system are visible, assuming you have the right permissions from the organization, but they're not custom to Marand as a CDR builder or to EtherSys. This changes the interaction between app developers and the health organization. It gives the health organizations complete control over their data and their data structures. The CDR provider is just a dumb database at one level. I mean, it's a smart database, but in terms of their ownership of the data or the data structures, they just take whatever they're given. Changes the commercial arrangements, changes the whole paradigm of how we build health systems completely. Here's an example of vendor-neutral querying. We loaded up the same data into 2 different CDRs, one from Ocean Health Systems, one from Marand, ran the same queries, got back the same data coming back. Building one of these CDRs is actually not an easy thing. Those of you who are technical recognize there are some challenges in there. It's easy to build a kind of dumb CDR that works kind of slow and sluggish. Making it work fast, making it work performantly, getting AQL right, all of that sort of stuff is, that's a serious engineering problem. So when anybody comes to me, whether they're a giant company or a small company, I say, look, don't build one of these things right now. You can do if you want, but start by using someone else's. And the good news is that there are a number of choices on the market now, including a couple of open source examples which are maturing quite nicely. And that would be my one message. For any of you who are interested in this, even if you think you have the engineering capacity to build one of these CDRs, you probably shouldn't. You should go and make use of one of the existing ones, if only to get everybody up to speed on this rather different paradigm of the way that you interact, your apps interact with the data. Because this is all about enabling app development. It's not really just, in fact, it's probably not primarily about interoperability. You kind of get interoperability out of the box in a way. If you use the same archetypes as the next company or the next organization, if you use exactly the same templates, you will get interoperability. But this is more, I think, about rapid data set deployment, rapid data set development and deployment. And it's used in many systems around the world now. This is a large infection control system that's run by Ocean Health Systems that Heather and I both used to work for in Australia. She'll tell you more about that. Here are some of the projects that I've been involved with personally. Eurotransplant, which is a cross-national transplant organisation based in the Netherlands, running on openEHR. The one in the bottom left, as a former GP, it was so much fun for me to help build a GP system in Norway, brand new, all based on openEHR archetypes. Genomics England, John Reed's going to talk a little bit more about this project later on. And the one in the top right is one I'm actively involved with, which is a national health record in Finland, again based on openEHR. So many, many different kinds of application. As an example of reuse, this is the Genomics England gel data set. We built 26 of these templates. So this project is all about rare diseases and cancer. And we used 99 archetypes, so these are the components. 44 of them were international ones out of the box. 27 were the international ones with some local tweaks, and 28 were purely local. Now those figures are actually a little bit skewed towards less reuse, and that's because this was a rare diseases. So rare diseases have rare kinds of observations, rare kinds of examinations. So it's skewed towards less reuse and more new build. Typically, I would reckon that 70–80% of the content in all of these other projects, 70 to 80% comes from the international shared repositories. So you get a huge amount of value out of the box in any project. All things that traditionally somebody like me would be helping an application or system developer to figure out what all those data models are. That's a huge cost and resource and time saving. In the UK, there are a whole number of examples of trusts and organisations starting to adopt openEHR. I know that Tomasz is going to cover some of these in his presentation later. And the one that I'm most interested in, because I'm originally from Scotland, although I don't live there now, is that Scotland have adopted what they call a national digital platform. So they've really got the open platform idea and have made this part of their core strategy moving forward. They're still working with existing vendors like InterSystems and the GP system vendors, but they've put down a marker that this is their strategic approach for the future. And the vision is to have something which is much more of a patient record off which multiple different vendor products hang. Right, but with a vendor-neutral, technology-neutral data store, and then allowing multiple applications sitting on top of that. They're also using another part of openEHR, a thing called GDL, which is kind of like archetypes for business rules. So a Swedish company, Cambio, have developed that, and Scotland have adopted that as part of their national clinical decision support strategy. So these are the first, NHS Scotland is just getting off the ground. The very first application that I was involved helping build is an end-of-life care application. It's a modern version of that very first form that I showed you around its patient's end-of-life care wishes. Do I wish to be resuscitated or not? That will be going live in the summer. The other one there, the second one, is the quite clever app that tracks patients' data collection when they're in a road accident. So this is being developed by an emergency medicine consultant in Glasgow, and it collects data all the way through different phases, from the minute that the paramedics arrive and start taking information in the ambulance, into the accident emergent department, into ICU, all the way through. And they're platforming this on openEHR. The data will live on the national data store, not inside the individual application. So it's very forward-looking and I think very exciting project. For those of you interested in the principles, you may find this a useful document. I was a co-author. It's published by the Aperta Foundation, so not-for-profit in the UK, which aligns some of the principles around this open standards, open platform idea. We're going to be talking later on with Graham Grieve, we hope, who's the the grandfather of fire. He's Mr. Fire. And you'll see, there's often discussion about should I use openEHR or Fire? And that's not the right question for me. It's how do you use these two things together? Because they don't try to do the same thing, and if you try to make it into a competition, you're asking the wrong question. These are complementary technologies. There is overlap, there is opportunity for us to work closely together. In fact, we already have. One of the archetypes that we developed for allergies and the Fire equivalent resource called allergy intolerance, we actually jointly developed using some of the openEHR tooling. We'd like to do more of that, but it's difficult to coordinate at times. So these are not competing. These are complementary technologies. Something else just to think about, and I think this is, for me, is an exciting thing in the future. Once you've got this idea of an open platform, you genuinely start to open up the potential for having what we've called a co-produced health record, where the patient-held record has always been thought of as a good idea, that the patient control the data. My problem with that is, up to now, it's been seen as a kind of lifestyle or wellness product. You measure your step count or your Fitbit, and I thought that's not real medicine for me. Medicine's when people get sick. This idea of open platform coupled to a patient-held record where patients have got full access to the information, but it's effectively a professional data store. What we're doing here is proposing that patients come in as professional partners, and they abide by the same rules of data quality and data provenance that we all do in the professional space. And I think this is very exciting. It doesn't have to be on openEHR. We know there are other companies and organizations using different technologies, but this really gives, I think, a very substantial change to the way we think about patients' interactions with their records. So what we're trying to do here, in a sense, is to rewire health IT at a fairly fundamental level. We don't have to do it all at once. It doesn't need to be a revolution. It can be an evolutionary change. It's hard for some people. When I'm giving these talks or workshops, very often I find there's quite a lot of reaction. How will this work? What do you mean I don't see the data tables? The engineers get really uneasy about that. But it feels to me like the right thing for the future. People who've been in this business for several decades, lots of companies internally are going, we don't want to keep rebuilding our databases every 10 years. This is killing us. This feels like a technology that will scale for the future. In a sense, what we're trying to do is to commoditize a lot of the really hard stuff that new entrants to a market will find. And a lot of that is down to the complexity of the data modeling and the data itself. We're trying to lower the cost and the barrier to new entrants and indeed to legacy systems. So just a comment on standards. This is the end of a whole series of slides that I don't have time to do, talking about standards and using comparisons with electricity. And the website that I took this from was saying one of the interesting things that's happened in standards for electricity is that the DC current, direct current, has made a comeback. So there was a big battle at the end of the 19th century about whether national electricity systems would be built on DC or AC, and AC won. But then in every hotel room now, you've got a little DC USB charger. So USB is actually bringing DC back into the market. And this is how standards do evolve and change. I always think we should be talking about standardization, not standards, because they are not set in stone. They have to evolve. Pleased to hear, having just got USB-C on my nice new MacBook, I hear that the USB guys have published this in April of 2015 to say they're working on USB-D, which came as news to me. And what they said is, now with USB Type D, no matter how crazy your night has been, we guarantee that you'll be successfully able to plug your phone in before passing out. So that feels to me like real progress in the standards department. It does say it's April the 1st, 2015 was when this press release came out, so it may not be entirely honest news. Thank you.